The ds-incubator continues on the series about the R package reprex for reproducible examples in R. And today's meetup is a follow-up of CJ's comment last time, the idea of what makes a reprex good or excellent, if you want. We're going to be talking about this article that exists in the package reprex, so in the website of the package reprex. It's called reprex do's and don'ts. And the objective is to learn precisely what you can do to make a reprex something that will help you and others have a more productive conversation about that code. So I'm going to talk about each of the topics that the article mentions with a little bit of an example that I came up with or extended from what I saw in the article. My goal is to try and finish with plenty of time for discussion, because I feel that some of these might not be so clear-cut. And also the way we think about the code when we write a reprex might not be the most natural when you just write code for yourself. So the first idea is that when you create when you create a reprex, usually you need some data. And the first idea is to try and make that data the smallest, simplest, and most built-in possible. So, for example, you may be tempted to start your to share reprex like the one here, where I'm not showing what we actually do with the data. It's up to you. But the reprex could start with something like this, where you have some data in your computer, somewhere in your computer, and then you do it. You share that data in a way that is somewhat reproducible, but it's not the simplest. So, for example, here I'm reading a data file from my computer. I'm using this clever function here that is aware of what a project means, and then if I share the link to the project on GitHub, the person on the other end, could download that project, could pull it with Git, and then if they run this code from that project, it will work. So let me show you what this kind of would look like for the person on the other side of the world, just to make another case for why this is not ideal. So while this is reproducible, I have that project. I'm running this code from inside that project, pretending that I pulled it from GitHub. And it has been annoying. I had to go to GitHub to do something. I had to add something to my computer, like a project. And then, when I print the data, it's a relatively large data set. I don't even see the top of the file. So here it is. So this can be improved in a number of ways, right? It can be smaller, it can be simplest, and it can be more built-in. Well, the idea that it can be smaller is relative to your problem, but many times, we're sharing data that could be reduced to a smaller snippet, and that's the idea. So, for example, let me show you what could be better than that. So better than that could be to use, if you're familiar with empty cars dataset, you know that this is the empty car dataset. But pretend that it's not. Pretend that it's something very similar to the empty cars dataset, but it's a dataset that only I have, and I really need other people to go to GitHub and get that data. But if there is a way to use the empty cars dataset, which is super boring, then you should, because the point is not to share exciting data sets. The point is to ask people for help for a specific problem. So you should keep focused on that. So yeah, use empty cars data set. It's more built-in. And instead of sharing it entirely, if you can make your point with just the head of it, just a few rows, then great. And then when they print that, they're gonna get something that is more digestible. So they're gonna do something like this, and they see already only a few rows that will be kind of easier to digest. And you can still do better than that. In this particular example next, I'm showing only 2 columns, because let's imagine that the problem can be explained with just 2 columns instead of all of them. And I'm also kind of showing how you can create a little data set that is random yet reproducible. So here the trick comes from using in combination the function sample with the function setSeed. So set seed, what it does is sets the random generator to a particular state that can be reproduced. So it will help you create numbers that are random but reproducible. Someone else runs this line here, they won't gonna get the exact same, in this case, object rows. So what we are doing here, this function, the way it works is, you tell it what is the object that you want to sample. In this case, I want to sample all the number of rows that empty cars has, which is 32, just because I know it. And from those 32 numbers, I want to sample just 2 of them. So object rows here has just 2 numbers at random between 1 and 32. So effectively, this what's going to give me is always the exact same data set that has only a couple of rows and a couple of columns. So if they run this code again and again, they will always get the exact same couple of rows and columns. So if you want to make a case or show an example for something that can be explained with this tiny data set, then go ahead. But we can still do better than that. For example, some functions have the ability to create data on the fly. That's something that is not very used in production, when you're actually doing analysis, but it is quite used in examples. So if you look at examples of for example, read-r package, you will see this type of way of creating data on the fly directly inside a function. With the read.csv function, you can create a data set inside the function if you use the argument text, which is not the first argument. That's a little different to how read_csv works from the read-r package. But if you are familiar with a comma-separated file, a CSV file, then this is what it looks like. In this case, the first line here, highlighted, is defining what are the column names, mpg, ceil. So that will create 2 columns, one mpg and the other was ceil. And then I'm creating a line break with \n. And then under mpg and ceil, I'm going to get the numbers 18.7, 8. So the first row, and then again another line break, and then again another line of data. So if I run that code, I get this. So see how succinct it is. It's pretty simple. Maybe the complexity comes from people not knowing that you can create data on the fly with read.csv, but once people pass that shock, then it's pretty straightforward, and you can get very quickly to the point that you want to make. And then there is another really nice way to create data on the fly, but I'm going to use that also as a way to explain another point that is very well made in the article Do's and Don'ts, which is this idea that you should include commands on a strict need to run basis. So basically add whatever you actually need, or not you, like them, so what the other person needs to run, and do not add things that they don't. So for example, let's begin by showing that, extending the example that I showed before, where we set the seed to a particular predictable or reproducible state, and then we create my data. Oh, here I missed the assignment, but still this is assigning my data, empty cars, these random rows to my data. So this is the data, and there is a very cute package called datapasta that allows you to create something like what you see here below, which is called a tribble. It's a function, or it's a tibble, but the function tribble of the tibble package allows you to create these data structures. So the beauty of this is that it's very readable. So you see already the content of the file even without printing my data. So sharing something like this is really, really nice. However, and so I encourage you to learn about the datapasta package, basically, right? But you generate this nice tribble with this, right? With this line here. But this reprex is bad in 2 ways. One is because it contains this code. If this was my reprex, it would be bad in 2 ways. One, this thing is set up for me as the one who creates the reprex, but it is not necessary for the to make my point about the example I may want to share. So this should not be in the reprex. And then there is something actually missing, which is the package where this comes from. So this is the table package, the one that has the triple function. So if we improve it in those two ways, so we remove what they don't need and we add what they do need, then our reprex becomes library table, because of course packages are part of what you need to include in your reprex. Otherwise, this code won't work. And then, the triple that you created behind the scenes. So the function dput is similar in that it also allows you to create with code a data structure that you can share. So for example, if I do library table and paste the code that I show you there, now my data has that data structure. So I could do dput my data. Let me make this a little bigger. I'm going to clean up with Control L and now run this. So you see that there is a bunch of text here, and that is the output of dput. So you can copy this from the terminal, that this is exactly how it works. And then in any file you can paste that code, and that you can assign it in this case to my data. And this you could share with the world. And when they run that, so I'm going to show you, even if I restart my session here, let's clean this up. And now I'm going to run those lines 1 and 2. And you can see that now I can do my data, and that will print the object. So this effectively did the trick. The only issue is that it's kind of hard to digest the output, a lot harder than the triple. So prefer that if you can. Otherwise, make sure that you can format it nicely. I'm going to press Shift Control A, for example, and get a little closer to a nicer layout. I'm going to tidy this tiny bit, and now I'm pretty happy with what I see. Maybe like that. I will show you like that, or maybe like this too. Okay, so next topic is the idea of considering to include the session information. So session information is a function that is built in the, I think it's the utils package. It comes with R for sure. Session info. Okay, so there's two. One that comes in DevTools, which is an add-on package, and then utils, which comes already with R. So that function will print useful information like what packages you have, what versions of the packages you have, and a few more things. For example, where what's this system that you're using here. I'm using Ubuntu, for example. But reprex also has the ability to do that. So if you created a reprex with this command here, remember that the reprex function, you can pass multiple lines of code inside curly braces, and then extend your reprex with arguments. The argument session info. If you set it to true, we'll add the session information there. So actually, let's show you what that looks like, because the one cute thing that has is that the session information is collapsed so that it's still readable, but doesn't kind of clutter the view of the reprex. So I'm running that, and here on the right I got the output, and you can see this drop-down menu. Takes a little bit to refresh here, but here it is, right? So it's a lot of information, so it's kind of nice that you can collapse it and get it out of the way. Another topic is the idea of being generous with white space, because it really helps understand or read the code. If you don't, then you can always use the style equals true argument of reprex, and that will style it for you. It's powered, I think, by the styler package behind the scenes. So for example, the reprex here, I'm highlighting here, does not have spaces around the assignments, either here or here, for example. But if I run this reprex, the output will look like this. And as you can see, now there is space around the assignments here and here. So yeah, that's it. And then the one last topic is one that it's kind of nice to end with this one for discussion, because that's probably where I envision a lot of maybe comments or I don't know, questions about that, which is this idea of not taking a liberty with other people's computers, because you are asking people to run your code. Maybe they may not need to run it, because reprex is designed so that they don't have to if they don't want to, because they see the output. But if they choose to, then they're going to be running your code. So you don't want to do some things. What are those things? Well, things like this. So let me show you in the form of, okay, what's good to do and what's bad to do. So it's good to assume that the other person will start from a fresh R session and work with that idea in mind. So you too should generate anything that needs to be shared in that reprex from scratch with the script. So just start by restarting your R session. You can do it. I can do it with Shift Control F10. I think at Max now on our studio on a newer version, I think there's a more ergonomic keyboard shortcut. I think it's Shift Command 0 or something. What you should not do is remove list ls, because that will completely trash the global environment of the person who runs that code, and that means that you are destroying information that the other person has in their computer. So that's a bad thing to do to someone that is trying to help you. It's rude. Also, don't use a working directory that only you have. The function here helps you do that. So it's 20 past, thanks CJ. I'm aware of that. I think I'm going to be finishing in maybe 3 minutes. So one good way to share a project, to share a path or a file that is inside a project that you have, is to make it available publicly on GitHub, and then you just share the link to that project so they can pull it and then do their thing. As I said before, if you can avoid that in some way, it's better. But if you can't, then okay, that will do. That will make the code reproducible. What you don't want to do is to not share the project and then just, for example, set the working directory to that path that only you have, because someone else won't be able to reproduce your code. So it kind of defeats the purpose of a reproducible example. Another topic is also in terms of not taking liberties on other people's computers, is to not define a function with the name of a built-in function. So something that already comes with base R. Don't write another function. Maybe an object that is not a function, it's fine, but a function that overrides the behavior of the base R function is not a good idea. So for example, here I have a function that I created. I called it commas, and you pass it a bunch of objects of independent strings, and then it creates a single string with them two separated by a comma. So I could be tempted to call this function just C, but I would not do it. That could be bad, because it could be overwriting the function C that comes with R. So don't do that. Then it's the matter of options. There are many ways in which you may want to tweak options. For example, in this case, I'm changing options, the option called digits, so that when I print a big number, it only shows me a total of 2 digits. So here the number pi prints 3.1 only. And it's good to then, when you're done with that, reset the options to what they were before. And you do that by first storing the previous options in an object and then passing it back to options. That is a very weird interface. So very likely when you find yourself needing this, go ahead and read the help file of options to refresh how to actually use it. What is bad is to set the options and then just forget to set them back, to just start using your code and end your code and just leave the world in a state that is different to the one that you found it. So the takeaway is that just leave the world exactly as you found it. Then if you create files, then also delete them when you're done, because again, you want to leave the world as you found it. So if I create a file to remove.txt, it is good to do my thing, and then when I'm done, just remove that file. And what's bad, of course, is to just do your thing and leave the file behind and never remove it. So one way in which you can do remove files automatically is to just use temporary files. So R has a temp file and temp there, which for each session is a different temporary directory. So if you create a file with temp file, then you don't need to remove it at the end, because it will be auto-removed when you restart your R session. So that's fine. So finally, don't delete files or objects that you did not create in the first place, right? So if you did not create a file, don't delete that file because it's the helper's file. And if this all sounds like a lot of work, it's true, it is, but also consider you're asking other people to do work for you, and many times they take a really long time to digest your example and to prune it so that they can understand it. So it's a good idea to go through these items to make your reprex as excellent as you can, because most of the time you will not even need to share it, because along the way you are sometimes helping yourself and finding the solution. And then when that doesn't happen, you still have an excellent example that will make others more happy to help you. So that's the end. That also is here, the Bing for a comment or question. So I'm going to jump back to our conversation. And that was CJ. Go ahead.
Yeah, so first of all, thanks for following up on this, because I think it's cool, an important part of this series that you're doing. So I have a bunch of comments, so I'll just throw a bunch of them out there quickly, I guess. And so one thing in your final section of things not to do, I would add in there, don't install any packages, because a lot of people tend to put this install.packages in there. I find that really annoying. I should also clarify from where my perspective is coming from, which is I have answered many questions on Stack Overflow. I've dealt with this over and over again, and as a person trying to answer people's questions is honestly quite annoying. Trying to work through some of these problems, that would be a lot easier if people followed these examples and advice.
Yeah.
So not installing packages. I would also go a step further with accessing the file directory and just say you should not do that ever, reading or writing, unless the problem that you're trying to show to someone is within this process of reading or writing your files. So if you want to have a problem with a function that's not working the way you want, but in that process you're reading the CSV or writing the CSV file, something's wrong. That's definitely not necessary in your process, or it could be or should be re-implemented in some way which doesn't touch the file system, like the ones that Mara was showing, where you can read a CSV from the text. I also wanted to mention, with the data files, this is really important also topic, creating these data files that you need to demonstrate your problem. And Mauro did give some good options. I also highly recommend this data pasta package, so I'm glad you mentioned that. One slight disadvantage, so I really like the output of the tribble that data pasta creates, because that function reads in data that looks like you can actually read it when you post it right on Stack Overflow or an email or something. You can already tell what the data is going to be, so sometimes you don't even need to put this stuff into R. Sometimes I can read it and say, look, okay, I already know what the problem is. So that's really cool. The disadvantage with Tibble is it does depend on the Tibble function being installed and also loaded before that works. So I've worked with some alternatives, and one is very similar to the read.csv that's reading in text. But just so you know, one thing that makes that a bit more readable is you don't have to put the line endings in the character string. You can actually put actual character returns, so you can have a new line for each part of the CSV, so it kind of looks just like a CSV, like a mini CSV if you had opened it up in a text window. So that's kind of cool. It makes it a little bit more readable.
So that's a feature that comes already with, for example, the text argument of read.csv, or are you mentioning some package that is an extension?
No, exactly. It's just part of read.csv. When you use that text argument, you can replace the \n with an actual carriage return, and then it looks like a block of text that's multi lines. And it's a bit more readable. And then similar to that, but slightly even more readable, in my opinion, is the read.table, which then can read a table of text that's delineated by like either white space or a tab or something. And then this is very readable just straight away. So, I mean, these are just an alternatives to, say, using the Tribble, but it gets around the cost of using a package that the person that you're trying to share it with may not have installed. So I'm copy pasting into the messages if you're interested to examples of these. And then one last comment about the data. So we talked about like how to create the data in the code, which is great, but there's another aspect, a contextual or conceptual process that one should usually go through is minimizing these data sets. So what I often see is people like, they don't take the time, they're just like, yeah, I want to use my data set that's like 100 lines long, and then they want to copy paste that version. Like even if they've converted it into this Tribble command or something, it's still way too long. And so yeah, I'd like to encourage people to also consider like, do I really need all 100 lines of this, or do the first 10 lines of this data set get the point across? And if it does, then definitely cut it down to 10 lines, because it reduces confusion and it makes it easier for people to read your example and help you.
Thanks, EJ. I was trying on the background. I don't know if you noticed that feature of read.csv. Yeah, I really like it. Really cool. Do we have more comments or questions here? Also, I wanted to mention this link here at the very end of the article that kind of holds the demo of today. It is a link that exists also on the reprex do's and don'ts, and it's beautiful because it is talking about what makes an excellent reprex 10 years before, or like 8 years before reprex existed. So I think it's important to honor that Stack Overflow post. Also, I think it's an excellent example of how to write a good post. So not only gets to explain what an excellent reprex is, but also in itself is an awesome example of how to address how to answer questions there. So pretty much goes through everything that we have covered today, and in a more general way because it's not associated to the reprex package. So I invite you to go ahead and have a quick look at that one there. Okay, we are about to end then. Last chance to ask any question or make any comment. All right, then thank you very much. I see you next time with the last chapter of this series.
Thanks, Mauro.
Ciao, ciao.